webinar. He is a ready engineer before he jumps into the industry. He worked hard with us during his academic tenure at Kennedy University. He developed his practical skills. He know how the electrical and mechanical systems interconnected and how important to understand those before working on the system. So this is our core message and our profile, being a team member and the founder of PAK-DTS Technical Solutions. Thank you very much, Ali Ahmed Sabri, for joining us. You are a bit late, but again, finally you joined us. We can go on another slide. Yeah. So this is our team. I love to see that picture. And me, Nayyar Ahmed, Ali, Nadeem, Abdul Rahman, Mazhar, Niaz Muhammad, Azbia Shakur, and Sayyid Ammar Hassan. So everyone is actually a very specialist in their field. They are very practical. They are application engineers, and they are uh, for me, they are like a core pillar of Park Dynamic Technical Solution. You can more find us on our social media links, which we have shared in this slide as well. The next slide, Ali. Uh, Go back. Yeah. So to explore more about us, you can visit Park Dynamic Technical Solutions, the YouTube channel. You will find many videos are there, and actually some more videos are in progress to produce and publish on YouTube. Those could be like a very high niche sophisticated diagnostic procedures for European cars, especially Audi, Mercedes, BMW, and also Range Rover. And diesel electronics, plug-in hybrid, and high sophisticated Audi electrical technology as an independent European vehicle specialist. And then you can also connect us on Park Technical LinkedIn. We can go on another slide, Ali. Now, our bullet points for this webinar, why we came back on social media, online presence to arrange this webinar. I am living in Australia. Ali is living in Canada, and Ali Ahmed Sabri is living in Pakistan. So we all working in different regions of the world, and actually they are very developed countries in terms of technical advancement and technologies. So we are gaining insight of that industry somehow. As a member of Park Dynamic Technical Solution, Ali is handling Canada and most likely in near future America. I am taking care of Australia, and Ali Ahmed Sabri will be a part of Pakistani team soon. So we share our experiences, we share our challenges, and now this webinar we bring here to especially for our Pakistani participants. Either they are industry professionals or they are from university uh, graduate students or they are technical trade persons. So this webinar explains university and industry gap, practical exposure for grads. What is the practical exposure? What practical experiments you do in the lab and what happen in the industry? Sudden breakdown. We need a root cause analysis for that sudden breakdown. Why this happened? Because of lack of maintenance, lack of periodic maintenance, or the part or itself the part is not good, or the system design is not really accurate. So there may be inaccurate. So we have to analyze from these perspective, either this is a maintenance problem, this is a part problem, or material problem. Maybe the material is not good, and over time it becomes fragile or it becomes erodes, and then this problem happen itself. The maintenance was carrying out very good, the periodic maintenance was on time. So these things only comes when you enter in the industry. So why we are here, we are bringing up our expertise, our reliability engineering, maintenance engineering, and also the design and material selection engineering. That's why we arrange webinar, and this is actually only one part of this webinar. Real systems understanding. Industry wants problem solvers, not just graduate. There is a very deep hidden message in that last line, because when you go to developed countries, the practical approach is really important. If you go to Middle East, if you go to northern countries, if you go to southern pole countries, they just need a solution. What the engineer mean, what the technical specialist mean, they need solution. With the paper tag you brought with them, you can do the solution or you cannot do the solution. That is only important for them. Nothing for your chapters, for your grades, for your GPE. Maybe your GPE will mean for your master's admission, for your PhD research, but for industry, they only know what you can do or what you cannot do. And your employment, your progress, your growth depends only your capabilities, not your paper. The paper is just telling them that yes, they can hire you, but sustaining that job, growing further, you really need to understand that what you can do for them and what you cannot do for them. We can go further. The next slide, please, Ali. Yeah. So now, what mechanical engineers are doing in industry actually. Okay, design and implementation. Understand like this. I give example of Pakistan. We have water shortage, especially I belong to Karachi. Ali belong to Karachi, and also Ali Ahmed Sabri is living in Karachi. We have a water shortage in Karachi, and we have one overhead tanks, water tank. Once it fills, then overfilling and then wastage of water we can see everywhere in Karachi. So normally when a power supply is available, water supply is available, what happened? The water is overflowing and then it's wasting on the road. That is the pure filter or drinkable water or a usable water which we are wasting. If it This is the problem. Now what's the solution behind design and the design and implementation? I want to design a system in which water tanks, they have a water level sensor, and once they fill, water level sensor sense that, and then it stops automatically the motors, and then water wastage will be controlled. This is the design and implementation theory. Okay. Then we have a maintenance and troubleshooting system optimization. Now maintenance and troubleshooting. So something happened to the sensor. Uh, there is a breakdown in sensor. Overfalling of water is continuous and is not switching off the water supply motor or induction motor, which is supplying the power, which is supplying the water. Sorry. So we have to understand that what we can do. We have to check the motor. There is many maintenance strategies available. Then we understand as an engineer, not as a trade person, we understand why it's happening again and again, why our repair cost is increasing. We have to understand that there are some inaccuracies in that system that demands continuous maintenance and continuous troubleshooting. Now there is second phase, system optimization, continuous improvement. We have got the feedback from maintenance and troubleshooting department or maintenance troubleshooting engineers. Firstly, we design, we implement. Through the continuous maintenance troubleshooting, all the problem occur again and again. So we found that we have to find a solution. Now we have improved our system. This is called system optimization. And then in the last, real-time decision makers. Engineers make critical on the spot decisions during operations, responding to unexpected challenges and ensuring system. Now, let's suppose your car is breaking down. There is a message on that you cannot drive or drive safely. and there is a overheating problem. So now you have to understand that how long you can drive it, because every overheated car is not actually a broken down. We have to understand, depends on the model and brand. We have to decision. Now engineer, what engineer will do, they will decide we have to run safely or we have to get it on recovery. They understand the system and they make a decision to bring the problem, to bring the solution as soon as possible. So real time decision making is just comes if you understand design and implementation, if you understand maintenance and troubleshooting, if you understand the system optimization, that what improvements were brought into that system. We can go on the next slide, Ali. Uh, we can go on to the next slide, Ali.
Oh, just wait. I think there's an issue.
You okay?
Yeah, yeah, yeah. Yes. Yeah. All good.
Now, real industry challenges: equipment failure. Some equipment fails because of wear and tear and their life finishes. Some equipment fail because of external pressure or the system pressure. Some equipment fail because of their material, and some equipment fail because of their design. Okay, so we have to understand why it's happening. Unexpected breakdown. These breakdowns affects productivity, production, and definitely sales, and then industry goes shut down. So if we understand this criteria, time pressure, then cost impact. Now there is no textbook solution for, let's suppose I talk about packaging industry. There is a conveyor belt. We have two cases. There is a conveyor belt, and then we use, let's suppose, RF sensor. RF sensor, when they detect the object, they give the direction. So normally what happen on conveyor belts, when the RF sensors are there, they give the direction to packaging objects. If RF sensor is faulty, they will not give the direction to packaging products. Those are driven on the conveyor belt. What happen, they will go into the wrong direction and they will fall down on another unknown places, and which disturbs the production, which disturbs the transportation and packaging as well. Okay, so cost impact and then time pressure. So that's why these things are from reliability engineers, reliability engineering, especially from plant maintenance. We can go further. Another slide, Ali. Okay. Everyone can hear me properly?
Yeah, I can.
Good. Just raise your hand, thumbs up, or you can say anything. Okay. Interdisciplinary engineering. Modern engineering involves mechanical systems, electrical system, electronics, software, and control. Why I'm focusing on that, because I work on small objects, especially my specialty area is European vehicle technical specialty. So every car nowadays, regardless it's electrical, it's hybrid, or it's a modern sophisticated electronically engine management control systems, every car has a interconnection systems. Okay, so we have to understand mechanical system, electrical system basics, electronic system basics, software and control. That's why I love the engineering courses. They, as a basic, I study electrical engineering. During my studies of mechanical engineering, there was a subject electrical engineering for mechanical engineers. And now I understand after several years of experience, especially working in Australia, that why I was taught electrical engineering during my studies of mechanical engineering. So they all are interconnected to gain the maximum control, drivability, and productivity. We can go on another slide, Ali. Okay. Now we have one more automobile example. Actually, mechanical engineering everywhere, interconnected engineering in everywhere, but we use a modern automobile because this is our trademark definitely. So mechanical side we have engine. Sensors is electronics, definitely they are an input device. ECU is software, actually it's a processing device with software and hardware. And they get data from input switches like sensors or switches. And then wiring, that is electrical transportation. We have one more thing, those are actuators. So actuators are the output devices. Now I give you one example if you all understand the technicalities of modern interconnected systems. So we have intact manifold in any modern car engines, and there is electrical actuator that operates intact manifold flaps to control the air. Now we are controlling fluid as a part of fluid dynamics, and how we are controlling, there is a mechanical flaps, those are controlled by electrically operated actuators, and electrically operated actuators get signals and voltage based on the information provided to ECU. Okay, and how they transported through the wires. Now you can understand how complicated and interconnected, not complicated actually, but interconnected connected systems are. When we explain the car, there is a flap. If it needs more air, flaps opens and then air enters in the cylinder. So if you go to and search after finishing of this webinar, what is intact air manifold flaps? So you will understand what is that. Okay. Go to another example, another slide actually, Ali.
Yeah, there's some issue with the presentation. I don't know what's happening. Uh, okay.
Okay.
Yeah,
So we have one.
all good.
Okay, you got it.
Yeah, yeah.
Okay. Yeah. So integrated is a combination of multiple engineering fields, multiple engineering interconnected, where we can see automotive manufacturing plant. As I told you that if it's a conveyor belt, it is the conveyor belt chain driven by induction motor, and there is a RF sensor for directions. Okay, and then your overhead cranes are operated electrically, and if there is a voltage disruption, mechanical cranes cannot be operated. Energy sector, definitely energy sector is also in the part of integrated engineering. And then HVAC sensor is heavily dependent on interconnected integrated mechanical engineering system. Why? Because I will give you just one example. We have a temperature sensor that is placed in condenser. So we need to know what's the condenser temperature, and then the cabin or the isolated air area which has to be cooled or hot based on the requirement. Okay. So we have to understand the automatic air control system. Once the isolated area, room or whatever the hall, its temperature reaches on that certain required temperature, who will tell the system to switch off the coolant or the hotness? The sensor will be inside the room or inside the cabin. It will tell, now the I have sensed that much temperature, please switch off or please switch on. So these all system like HVAC industrial system or the HVAC automotive system, they work same, but on the different systems, like some AC system and somehow vehicles are under 12 volt system, and there is a design system differences, but overall principle is same. We can go on another slide, please. Okay. Scope of integrated engineer, those engineers who understand what electrical is, what electronics is, and what is mechanical engineering and how we can interconnect it. I gave you one example. In Karachi we have overhead tanks, okay, or we have underground tanks. If they overfill, the water wastage is everywhere, we can see. Now if we understand how can we control this automatically or electronically, and it should be a really productive. I told you, install the level sensor same time, which gives the information to a controller. Switch off the motor please, induction motor, because tank is full now. Okay, this is now how I get on that to point, because I know that there is something that can be detectable by a device called sensor, which is called level sensor, gauge sensor, like that. Now I'll tell you one more implementation and application of gauge sensor. I worked somehow in one of the Navy ship projects. So we used to install a very large level sensor in propeller shaft room. Why? When there is a water intrusion, that sensor needs to measure the water level sensor inside the propeller shaft room, and then it needs to inform uh, uh, the ship control room that there is a water, turn on the motors. So the control room, because they have a control room, not controller or not a ECU. That ship was a very big ship, like 3 floor ship with the capacity of uh, 2,900 people. So control room operates the excavation motors. Those were responsible to drain out the water. So now this is the real implementation of integrated mechanical engineering. We can go further. The next slide, please. Foundation of all engine industries we have already discussed. Thermodynamics and fluid system. I already told you that air intake system, because the air is also itself a fluid, which is controlled by electronically and connecting with the mechanically flaps in intake. So these all things sometimes we miss in our theory classes or in our theoretical and academic period of university or any institute. We can go further then. Okay. Integrated systems example. I told you automotive is highly integrated system, extremely integrated. So far in 16 years of experience, I have never seen other than automotive system using IT, electrical, mechanical, fluid dynamics, heat transfer, material engineering, IT, and somehow mechatronics. You can say combine it with mechatronics. Then industrial plant system, definitely they have a control rooms. They so integrated system. HVAC system is definitely another example of integrated systems. We can go further. I think this is the last our slide. Okay, engine overheating. So overheating is a very critical issue with the engine. It can blown the engine. It can blown head gasket. It can uh, uh, be because of many problems. We can see the root cause analysis or in the next slide. If you can go on the next slide. Ali, you wanna shift on the next slide? Okay. Coolant issue. Radiator could blown, radiator damage, any hose damage, water pump damage. Even if the water pump belt is okay, if the belt driven water pump is installed or the electronically controlled water pump is installed, we have to understand the system so we can go on that to troubleshoot. And then inside the water pump there is an impeller. If the impeller is broken and is not enough producing the gravitational force to push the water on the required point. And then sensor failures, like sensor is not giving enough data to ECU understand that what actually engine temperature is. So it will uh, pop in the engine light or the message that overheating or the coolant system malfunction, please visit workshop. And then fan malfunction, like we have a mechanically operated fan that is on the mechanical side. So first thing is coolant issue. Maybe your coolant is leaking, it's not enough, that's why your engine is overheating. Or another thing, that your coolant quality is very bad. Due to coolant quality is also uh, making a problem that your engine is overheating. Maybe the coolant concentration with water is not enough, or someone is using only water. That could be the example. In Pakistan, mostly people avoid to fill engine coolant reservoir with coolant. They normally use tap water or distilled water, regardless whatever their car is, and it makes a problem, making high corrosion, which is actually I think material engineering. Sensor failure is an electrical problem, and then fan malfunction is a mechanical problem. We can go further. So a diagnosis approach, I already told you that how we can go through sensor data, electrical testing. These are the real practical things. I cannot go deeper in that because of time sensitive webinar. And then these all things can be covered in practical training or any practical webinar. We will further try to arrange some more useful technical expertise webinar as well. So maximum things I already told you. We can go on next slide again. Troubleshooting, basic electrical knowledge, yes, hands-on exposure. Uh, Actually, in hands-on exposure, this is the most difficult part. You have to spend time. It's a time-taking thing, and you have to be with seniors. You have to explore and cover your own failures while learning. Sometimes we fail, sometimes we adjust, and then communication skill. How excellent you are in representing the problem. Sometimes we are unable to solve the problem, but we have to communicate with others that I am failing on this, or I want to solve this. What could be the, so your technical background or your system understanding approach will lead you to the best communication skills, even if you are unable to solve or you have solved the problem, and you can make them understand in terms of like what parts you use, what system you adopt, what changes you made. So your communication skills will be the representation of your knowledge. We can go on next slide. Final message. I actually love this. I didn't write this. Ali Ahmed Sabri wrote this. Think like an engineer, not just a student. A student who always look for references. We must have a reference in industry as well. Service information, service portals, clouds, manuals, and then specifications, and then met conditions for inspection. Yes, we have, but we have to sometimes think out of the box. This is what the my final message is. And if you are engineer, from my side my message is become application engineer, become a solution engineer, or become a can do engineer, not a degree engineer. That's it from my side. Take care, keep smiling, be happy, but on your own expenses. And you can ask the question. If anyone has a problem asking question in English, we can continue to, not a problem. Yes. Is there any question from someone? Someone wants to ask any question?
So Arif is asking something.
Yeah. Maybe you want to ask something?
So he wrote in the chat. Uh, he's asking, is mastery in microcontrollers helpful in this subject?
Sorry, I didn't hear you. I missed. Say again.
So he's saying if masters in microcontrollers is helpful in this subject.
Yes, yes. Mastery in microcontroller is actually a significant scopeful field. If you have a mastery in microcontrollers, you can work in automotive, you can work in automation industry, controlling industry, and then PLC designing and much more. Microcontroller mastery. We will further introduce technical webinars actually. This was the launch of 2026 to get you in to understand that what we are bringing for you in future, and we have at least like 4 to 5 technical expertise webinar specifically blended and focused on real technical expertise. So not like in general engineering terms, but technical such as like how to use multimeter, how to test diode, how to test weight stone bridge, okay, and then how to architect ECU, how you use diode, and then you can use weight stone bridge, you can use microprocessors and the resistors. I tell you one thing, resistors can are used in ECUs. We have to arrange resistor values to design the circuit, and then we can get our desired data. Sometime if we I have to produce 5 voltage output from the ECU, how will I produce? I have a different concept of this. I will make an arrangement in ECU, and then it will draw 5 voltage for any actuator, for any sensor, most likely. So yes, microcontroller mastery is a very actually very valuable field. Definitely you have to be a very practical on that. Any other question? कोई भी उर्दू में भी बात कर सकता है, आप उर्दू में भी कोई क्वेश्चन पूछ सकता है, अगर किसी को क्वेश्चन पूछना है। तो उसके बाद फिर हम 2 मिनट में ये वेबिनार एंड करेंगे, क्योंकि पार्टिसिपेंट्स ने लेट ज्वाइन किया इसको, उसकी वजह से, अदरवाइज इट शुड हैव बीन फिनिश बाय 7:40 एज पर पाकिस्तानी टाइम।
Mhm.
किसी का और कोई क्वेश्चन है इसके अंदर?
I don't see anyone. Oh yeah, Ali Ahmad Sabri is raising hand.
जी अली, आप कुछ पूछेंगे?
Yeah, Ali, go ahead. What's your opinion in mechatronics in education system?
Actually, mechatronics is a front face of mechanical, electrical, electronics, IT, and GPS.
Hmm.
Okay, so mechatronics is a very, very good education. And what's your opinion on mechatronics in education system? Okay. मैकाट्रॉनिक्स को जो है वो इंट्रोड्यूस होना चाहिए पाकिस्तान में, और हमारे साथ जो अज़विया हैं वो जो हमारे टीम में वो मैकाट्रॉनिक्स इंजीनियर हैं, इस वक्त वो ट्रांसपोर्ट और प्रोडक्शन मिनिस्ट्री में शायद वो काम कर रही हैं। तो जो है मैकाट्रॉनिक्स की जो इंटीग्रेटेड डिसिप्लिनरी इंजीनियरिंग है, उसके अंदर मैकाट्रॉनिक्स की जो है वो एप्लीकेशन बहुत ज़्यादा है। सो नॉर्मली आप देखें कि जो सेफ्टी पर्पस के लिए हमारे पास अलार्म्स लगे होते हैं, उनको मैकाट्रॉनिक्स इंजीनियर इंस्टॉल करते हैं, उन अलार्म सिस्टम को डिज़ाइन करते हैं और उसकी ट्रबल शूटिंग भी करते हैं। ठीक है, सो इसलिए जो है आप नॉर्मली अगर हम कन्वेंशनल इंजीनियरिंग एजुकेशन पे जाएं तो ये काम मैकेनिकल इंजीनियर कर रहे होते हैं। तो इसलिए हमारा जो आज का वेबिनार है उसने ये कहा है इंटीग्रेटेड मैकेनिकल इंजीनियरिंग सिस्टम्स, बिकॉज ये सारे काम जो आज मैकाट्रॉनिक्स इंजीनियर या एप्लीकेशन इंजीनियर्स कर रहे हैं, वो पहले जो है वो मैकेनिकल इंजीनियर्स इसको परफॉर्म कर रहे थे। तो डेफिनेटली इसकी जगह है। अगर हमारे मैकेनिकल इंजीनियरिंग के कोर्स में ये सब चीज़ें पढ़ाने के लिए स्पेस नहीं है, तो फिर इसका एक कोर्स बना के वो मैकाट्रॉनिक्स इंजीनियरिंग के लिए पढ़ाना चाहिए, और इसका बहुत ही हाईली स्कोप अवेलेबल है ग्लोबली। बट अगेन एप्लीकेशन इंजीनियरिंग में, नॉट थियोरेटिकल और सिस्टम डिज़ाइन। गुड। So we should finish the webinar
Yeah,
now.
I think we
Yeah.
should
Thank you
finish.
very much for all of you to support us actually, and thank you for your time with us. I really appreciate to all of you in arranging such a great webinar. We will be continue that pace, that passion, and with some more technical expertise. Thank you.
Yeah, hopefully. Yeah, thank you so much, Shiraz. Thank you so much, Avi.
Bye. Bye.
Bye bye. Have a good
Bye.
day, everyone. Bye bye.